If you're looking to understand more about resistance, then this is a video for you. In the last couple of videos, we looked at what we mean by current and what we mean by voltage. It's really important that you have a grasp of these before we move on to resistance. So we've said that current is the rate of flow of charge. So we can say here that electric current tells us how much charge passes a point every second. So we can write it as I equals Q over T. We can say that anything measured in volts is referring to the energy which is carried by the charge. So we can write it as the energy divided by the charge. So it's the joules per coulomb. Just remember that some people like to write it as W over Q, where W still means energy. It's referring to work there. Potential difference, of course, is the difference in voltage between any 2 points on the circuit. And that's the one that's measured using a voltmeter. So what is resistance? Well, resistance, roughly speaking, is a measure of how difficult it is for an electric current to flow through something. In other words, if we apply a potential difference across something, a difference in voltage, how much current flows? Some things have a high resistance, which means not much current flows. Some things have a low resistance, which means it's easier for the current to flow. For example, the resistance of a human body is reasonably high. It's around about 1,000 ohms. If you look online, you'll find that figure varies according to conditions, but it's a reasonably high resistance of 1,000 ohms. Whereas a thin copper wire has a resistance of only about 7 ohms. So it's much easier for the electricity to flow through the copper wire than it is to flow through a human. A more precise definition of resistance, and the one that you should use in any exam, is this here. The resistance of something is defined as the potential difference across the thing that we're interested in divided by the current through it. We can write that as an equation, of course, where we say R equals V over I. So V divided by I. V stands for the potential difference, which we're going to measure in volts. I stands for the current, which of course we're going to measure in amps, and R stands for the resistance. And the units for resistance, which I mentioned a moment ago, are these things, ohms. We use the capital omega sign for that. The actual word is there, ohms. So how do we measure resistance? Well, measuring resistance is really quite straightforward. Let's imagine we want to measure the resistance of this bulb. Well, what we need to do is we need to find the two properties that come into our equation. We know that resistance is the potential difference divided by the current, so we're going to need pieces of equipment that can measure that. So we have a voltmeter, which is across, remember it's across the light bulb there, and that tells us in this case the potential difference is 10 volts. We've got an ammeter here, which tells us that the current is 0.5 amps. And remember that that is the current passing through it. The current goes around the circuit like this, passes through the bulb, passes through the ammeter, and comes back again. So all we do is put those numbers into the equation. Very easy. We know that we've got 10 volts of potential difference divided by 0.5 amps of current. 10 divided by 0.5 is going to give us 20, and the units, of course, are ohms. And that's pretty much it for resistance. If you found this video useful, then please do consider subscribing to the channel.